Okay, so I'm circling back around to the problem that is directly from your notes. So the integral of 5x minus 9 e to the negative 3x dx. Now, if you remember what I said if you have the natural log in it, that's u. If you have the e in it, that's dv. All right, so let's go over here and write these down. So u equals, okay, du, or the derivative of u. We also have v equals and dv, or the derivative of v. All right, so I said this should be dv. General rule of thumb, e to the negative 3x dx. Okay, which means what's left over is going to be my u. 5x minus 9. So let's see if my theory is right. Oops. Sorry, I didn't mean to write through that in my haste. Alright, so let me show you the formula. So the integration by parts, this is what I'm saying. Integration by parts. Integration by parts. The formula is, if you start off with a u and a dv, which we do, right? We've labeled these as such. This equals u times v minus the integral of v times du. Okay, so I'm not exactly sure where this formula came from, but you guys can certainly look it up in a history of mathematics books if you're so inclined. All right, so let's get to it. This says if you have u, then the derivative of that, right? Derivative of 5x is 5 minus 9. You also have to acknowledge that you took the derivative with respect to x. All right? So here we started with the derivative and we need to get back to v. How do we do that? We take the antiderivative of e to the negative 3x dx. All right, I'm going to zoom in on this so that you can see what I'm doing. I'm going to do the shortcut. You guys need to memorize the shortcut because we don't have a lot of time. Shortcut says 1 over this number right here. 1 over negative 3x. Negative 3. I'm sorry, correction. Not 1 over negative 3x. It's 1 over negative 3. Right? It's 1 over k, the number in front of the x. And then just copy it down. E to the negative 3x. And that's it. Okay, now oftentimes we would put plus c, that's what is appropriate, but for this process we don't need it. Okay? Okay, let's get to it. I'll start plugging things in as is appropriate. Alright, so this is the antiderivative of 5x minus 9 e to the negative 3x dx. This equals, alright, u, 5x minus 9, there it is. Right? It says multiply it by v, which is negative 1 over 3 e to the negative 3x minus the integral of v, there it is, we write that down again, negative 1 over 3 e to the negative 3x times du, which is this, 5 dx. All right, let's check. So let's just take a minute. Let me zoom out so that we can see both of them together. All right, we need to be getting to a simpler state. This one says 5x minus 9 e to the negative 3x. Notice this one does not have an x in it at all. So we're going in the right direction. Okay? So let's keep going, see what happens. So this equals, I don't know, there's a variety of ways you could write this. 5x minus 9 all over 3 e to the 3x. Okay, notice the e to the 3x can go to the denominator because of that negative power. Plus, notice I get a plus from subtracting a negative. Okay, 5 over 3. The integral of e to the negative 3x dx. So some of you are probably wondering, how in the world did she come up with 5/3? look, this is 5 over 1 right there. And I'm multiplying it by 1 over 3. So 5 times 1, 3 times 1. That's what's giving me the 5/3 of the coefficient. Okay? So this equals negative 5x minus 9. You could, of course, distribute that negative to the numerator, but I'm not going to. Plus 5/3. Wait a minute, I think we can do this. Right? I'm pretty sure there's a shortcut that I taught you guys. And here we go. 1 over negative 3 e to the negative 3x plus c. We're outside of the antiderivative, which is exactly where we want it to be. Right? Integration by parts is going to get you to a point where you don't have any antiderivatives left. So then your final answer would be negative 5x minus 9 over 3 e to the 3x plus c. 5/3 times 1 over negative 3, so negative 5 over 9. I guess we can drop the e to the 3x to the denominator plus c.